students, today's lesson is on multiplying integers. To start with, we're going to go ahead and multiply some integers that have the same sign. So we talked about this in class already. We know that when we have positive times positive, like 5 times 6, we get a positive. And then we also found by looking at all of those patterns that a negative times a negative is also a positive. So negative 5 times negative 6 would also be positive 30. So, there we go. Let's go ahead and write a rule. When multiplying two integers with the same sign, the product is always positive. So go ahead and take some time and pause and write this down. Now let's multiply some integers with different signs. So remember, when we looked at 3 groups of -4, we could have -4 counters, another -4 counters, another -4 counters. So we'd have -12 counters. So a positive times a negative is negative, and also a negative times a positive is negative. So our rule is that when multiplying two integers with different signs, the product is always negative. Whether it's a positive times a negative or a negative times a positive, those would both result in a negative product. Now let's do some examples with exponents. Now, we need to pay careful attention. There's some very slight differences between the first two problems. Notice that this first problem, -2, inside of the parentheses is squared. And then we have this -5 squared, but the -5 is not inside the parentheses. So in this first case, the base of the power is -2. So what we're multiplying is -2 times -2. We know that a negative times a negative is a positive, so that product is 4. That's different than this next example. -5 is not the base of the power here. 5 is the base of the power, and then we have the opposite of whatever this power is. So in this case, we have negative times 5, which is -25. So in this case, the end result is a negative integer, whereas in this case, the two negatives were multiplied together to get a positive. Here we have an example where we've cubed a negative integer. So the base of this power is -4. So we're multiplying -4 by itself 3 times. And when we simplify that, we'll have to say -4 times -4 is positive 16. But we still have this one last -4 as part of the expression, and then we'll multiply 16 times -4 to get -64. All right, one real-life application here. Here we have this bar graph showing the number of taxis that a company has in service. This number of taxis decreases by the same amount each year for 4 years. And we can see from the graph that it's decreasing by 50 taxis each year. We don't really know where we start and where we end, but that's not important to this problem. What it's asking is for the total change in the number of taxis. So if it's decreasing by 50 taxis each year, and that's happening for 4 years, then what we're going to do is multiply the change per year, which is -50, times the number of years, which is 4, and that tells us that over the 4 years, the taxis have decreased by -200. I should say it's changed by -200, or it has decreased by 200. All right, so I think that is it. All right, that's it for now. I'll do division with you in a different video, so go ahead and try a few on your own, and I will see you soon.